One of the things you need when you're going to be dealing with chiplets is the way to connect them together. There are standards like BO and UCIe that are available now. How would you wind up choosing one over the other, and are there other alternatives out there?
Okay, thanks, Bill. There's many aspects to multi-die design where the interface really drives the overall performance of the system. So when you first look at your system, you need to work out what are your main metrics. What are you looking for? Power, performance, area, latency. And those will dictate fundamentally which interface you use, be it a bunch of wires or UCIe. One of the advantages of UCIe is a very broad specification, covering more than just the electrical specs, but also all the way up through the protocol. So if you're looking for something that needs to be interoperable, you want to mix and match die with a third party, then you need to think about interoperability all the way up through the protocol stack, not just at the electrical level. So in that case, UCIe is really the de facto standard now for interoperability across multi-die. You may look at using a bunch of wires if your requirements are specific, maybe more captive, and you need a specific metric. Maybe it's density on the edge of the die. Again, UCIe can support both advanced architectures for packaging as well as organic substrate. So it gives you that flexibility to mix and match as well.
Now, what about UCIe? Does it support other things like debugging, security, things of that nature? Is that part of the mix?
Some of that is already built into the UCIe specification. There are requirements for some monitor capabilities. So on advanced packaging, the UCIe spec includes the use of redundant lanes. So if when you bring up that interface there is a dead lane, it can be remapped. So that's part of the specification. But not all capabilities are incorporated, and that's why you need a greater solution. You need monitor, test and repair from vendors like Synopsys, where you can build on top of that base layer of specified capabilities with more specific ones to help you with yield, to help you with debug, and actually mission mode testing as well.
Now, are there any features that are not in there that I would have to design in a custom fashion?
So security is one of those areas that is still being matured. So if you were to implement multi-die today, then you're going to need to work out what you're going to be doing for security. There is obviously a dream, a vision to add security compliance into the specification, but at the moment it's not there. So our customers are building custom solutions for security using the building blocks that we provide them. We have our root of trust, we have encryption blocks, and we have a methodology for bringing those all together.
Now, UCIe requires a little bit more than having a wired connection. Where do you get that IP from?
Yes. So as an IP provider, we provide multiple blocks. As a solution, we can implement and provide all of the parts for UCIe, which really consists of the electrical PHY, and then an RTL controller block. RTL, of course, portable across all the nodes, where the PHY portion is targeted at a specific node, be it TSMC, Samsung, Intel, or other. And that's where the challenge, of course, of building out a portfolio comes in supporting all of the nodes and all of the variants needed. And Synopsys is uniquely positioned with a huge, IP team, especially strength in analog design, to build out that full portfolio, so that companies can realize that vision of mixing and matching die from multiple vendors.
Well, talking about tools, how do you essentially partition up your system? Is it simply going with existing chiplets out there? Or if I have a design that I want to span across chiplets, how do I break it up?
Yeah. So Reality is there's no chiplet marketplace now, so that vision of being able to pull and mix and match die from multiple vendors isn't there. 2 years ago I said it was about 10 years out. I'm still on that timeline. We're about 8 years away from where there'll be a number of chiplets where you can put them together. So today there are logical partitions that our customers are looking at. If you look at high performance compute and AI, you can see that the AI component requires heavy compute, so they target the latest, nodes to squeeze the most performance out. But I/O or memory, that doesn't. The tempo of change is slightly slower there, so they are ripe for making them as separate die. So our customers today will logically partition across them. Synopsys, we have tools that help in that overall analysis. If you're not sure about the divide, where do you make the cut? We have tools as part of our full EDA flow to help with those partitioning choices and analysis and subsequent implementation.
Well, thank you for filling us in on how to connect chiplets together and some of the tools that might be available to make that happen.
Thanks for taking the time to talk to me.